Welcome to True Projects. In this video, we are going to explain about project titled Deep Learning for Smartphone-based Malaria Parasite Detection in Thick Blood Smears. The project focuses on addressing the global health concern of malaria, a life-threatening disease, and the difficulties in diagnosing it. The conventional approach for malaria diagnosis involves examining the stained thick and thin blood smears under a microscope, but this method is labor intensive and relies on the skills of experienced ones. To overcome these challenges, the project suggests employing the deep learning technique to automatically detect the malaria parasite in the thick blood smears utilizing a smartphone application. This automated approach offers a promising alternative to manual parasite counting and has the potential to improve the efficiency and accuracy of the malaria diagnosis. The project's objective is to explore the feasibility of utilizing the deep learning technique on smartphone for automated detection of malaria parasite in thick blood smears. This project introduced a two-step processing approach comprising an intensive-based iterative global minimum screening and customized convolutional neural network specifically designed for parasite detection. The study showcases the effectiveness of the method by achieving the strong correlation coefficient between automatically detected parasite and the ground truth, both the image level and the patient level. These results highlight the practicality and reliability of the proposed approach for accurate malaria parasite detection. The basic requirements needed to build this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement: Python IDE with version of 3.7. These are the modules that are developed to build this project. The first module is upload thick blood images. This first step is to upload the thick blood smear images that are to be analyzed for malaria parasite detection. These images serve as the input data for subsequent stages of the project. And the second module is remove noise. In this step, noise removal techniques are applied to the uploaded images. The objective is to eliminate any irrelevant and unwanted elements from the images that could interfere with the accuracy of the parasite detection process. This ensures that the subsequent analysis focuses solely on the relevant components of the images. And the third module is generate CNN training model. Once the noise has been removed, a CNN training model is generated. This involves the constructing a neural network architecture specifically designed for detecting the malaria parasite. The model is trained using the pre-processed thick blood smear images with the specific focus on distinguishing between the images that contain the parasite and those that do not. The training process involves optimizing the model's parameter to enhance its accuracy in identifying the malaria parasite. And the fourth module is upload test image and predict the parasite. In this step, a test image is uploaded to the system. The trained CNN model is then applied to this image to predict whether or not it contains the malaria parasite. The model analyzes the image based on the pattern and feature it has learned during the training phase. The output of this step provides the information about the presence or absence of the parasite in the test image. And the fifth module is predict the parasite from video. In this step, a video is uploaded to the system. The trained CNN model is then applied to this video to predict whether or not it contains the malaria parasite. The model analyzes the video based on the pattern and feature it has learned during the training phase. The output of this step provides the information about the presence or absence of the parasite in the video. And the final module is parasite and WBC count. In addition to the parasite detection, this project also involves counting the number of parasites and the white blood cells present in this thick blood smear image. This information provides the quantitative insights into the severity of the infection and aids in the disease diagnosis and the monitoring. The execution of this project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. Here the first folder, data, consisting of train folder consisting of negative and positive of resizing the images, and the dataset folder consisting of images of blood smears, and the model. Here in this model we'll have the .h5 files which contain the deep learning algorithm information. This .h5 file can be loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the predictions on the new data or performing the specific operations. And the test image consisting of the test data in the form of images, and the video consisting of the video for testing purpose, and the main file. Here it is an Python file consisting of the main code, and here it is a bat file. Here this run.bat file is used for executing the program instead of command line interface. We created this Windows bat file to execute the project. And here the video file is also an Python file. And to execute this project, we need to double click on run.bat file. And this is the graphical user interface we are interacting with this program. And double click on upload thick blood images button and select the dataset from this folder and click select folder. Here we get an screen like of images path is loaded. And click on remove noise button. After applying the noise technique, all the dataset images noise will be removed out and saved inside another folder named of data. Here in this data, it is saved in this positive folder after removing the noise from the images. It is not possible to show all the clean images, so I am showing only one image after cleaning the noise. And click on Generate CNN Training Model button. Here the CNN model is generated. To see the CNN layers, we click on the console. Here we can see that of CNN model is generated. The first layer start from the size of 126, 126 and 32, where 126 and 126 is the image height and the width is 32. Here in this way the CNN model is generated. And close and minimize this console and click on upload test image and predict parasite and select any one of the image from the test image folder and click on open button. Here that classifies as the test result is positive, means of that malaria parasite is detected in this image. And here we can see that of red color dots and non-red color dots. And here non-red color dots are WBC and the red color marks are of parasites in this image. And click on predict parasite from video and select the video from the video folder and click open button. Here we can see that of one image of consisting of different images in this video, and some images shows that the test result is positive and some shows that test result is negative. And click on parasite and WBC count graph. Here in this graph, x-axis represents the cell type and the y-axis represents the count. And this x-axis represents WBC count and parasite count and the values assigned for it. In this way, we can count the parasite and WBC count. In this way, the deep learning is used for the malaria parasite detection in thick blood smears. Finally, the project proposes a deep learner-based automated parasite detection method for malaria diagnosis using the smartphones. The proposed model consisting of two stages, that is parasite screening and classification. The proposed method has the potential to be promising the alternative to manual parasite counting, especially in areas lacking experienced ones.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.